Hello everyone. In this video we are going to talk about some of the challenges that we face when we are working on large language models. Most of the LLMs that you see they have a very limited set of knowledge, at least when it comes to the most recent events. Even when you talk about the most popular LLM right now as ChatGPT, even it has its knowledge until I think November or October 2022. But what about the most recent events? If I want some queries that needs to be resolved that happened in the most recent times, and it won't work. Also, when you want an LLM to behave in a specific manner, or if you want it to have domain-specific knowledge. Let's say I'm running a fintech company and I have some financial regulations, terms and conditions of my own company, and of course I can share this with the LLM, and I'm pretty sure that the LLM is not trained upon that. In that case, what I can do is I can create a huge knowledge base out of all the documents that I have. I can create a huge text file just like any notepad file that we have. You can put all your data there, and then you can push it to a vector database. Vector database helps you retrieve the results through cosine similarity search. There are different similarity search methods, but the cosine similarity works efficiently and it's the most popular one. There are a lot of vector databases. One such that I'm going to show you now is Pinecone. Through Pinecone, you can put your knowledge base over there, and as soon as I give a query to the LLM, it kind of works in a way that it triggers the similarity search function, which goes to the vector database, performs similarity search, and retrieves the most similar search results. And then it provides this answer as a context to the LLM, and the LLM will learn from it, and then it will generate an answer. This process is called Retrieval Augmented Generation. If you split this into the retrieval, because we are kind of performing retrieve, we retrieve the similarity search result from the vector database. Augment, because we use that similarity search result as the context to the LLM, so we kind of augment it to the LLM's response, and then we generate our final answer. That's why it's called Retrieval Augmented Generation. In this video we are going to talk about OpenAI's GPT model. We'll use its proprietary software, but still I believe it could be a good start in order to understand retrieval augmented generation in a lot better way. So we're going to use Pinecone. As soon as you sign up for Pinecone, this is where you land. And don't bother copying the keys, environments, or anything as such, because I'm going to delete this vector database right away after making this video. This is one such vector database that I've created. As soon as you click on it, you could see I have already put some data here. You could see some values, because these are all embeddings. Okay, so when you see, there are two things. The first one is tokenization and the second one is embedding. Tokenization is basically when you split the word into its root form. So let's suppose I have a word like dogs and cats. It will split dog, then the s, and then the cat, and then the s. So dogs has a root word dog. S is just an additional thing. It obviously adds meaning to the root word, but it's definitely not one independent word that you split and then you still have some meaning, right? So that's what is called tokenization, when you put a word and then you convert into like small tokens, and then you combine it as a chunk of tokens, and then you perform embeddings on it. Embedding is basically when you convert each of those words into some sort of number. Okay, it's more like a number. You could see it here. This is what embeddings look like. So it kind of helps you retrieve results in the best way possible. So the see, characters, machine cannot understand characters, right? So when you convert it into numbers, it's more easier for us to perform any kind of like in this case we are performing cosine similarity search. It works only with numbers, so that's why we perform embeddings. OpenAI offer their own set of embeddings. There are different models through which you can perform embeddings best fit to your use case. Here you can see, as soon as you do that, there are a few things that you need to keep in mind. I'm using metric as cosine similarity search, and then you have the dimensions. I'm using a dense vector database. Of course, everybody uses dense vector database for this kind of use case. Other than that, you can also use a sparse vector database, but we don't really have to, because it's very high dimensional vector database. And if I could give you an example of that, it could be if you're using NLTK, you must have seen bag of words. like when you start working on LTK, you will see bag of words as one such concept. It's an example for sparse vector database. Here you could see we have 1536 dimensions. It means like we have 1536 characteristics of like whatever the embeddings that we had performed. If I make it simple for you, let's say you have a data, age, and then the name of the student. This is 2 dimensions, right? Because you have 2 characteristics. This is of how we have 1536 dimensions here. And then you have some host link here, you have environment. This is also important, you have to copy this. And then you can go to API keys, and then you can get your Pinecone API key from here. Of course, I think you know how to get your own API key from OpenAI. So as soon as you're done, you can come back to your Colab notebook, and here you can see we're installing some libraries, LangChain, because we are working on LLMs, and LangChain is one of the most important libraries these days. And then we have OpenAI, we installing these specific versions. So I would suggest you to install these specific versions in order to make it work efficiently. Otherwise, you will have some kind of counter issues with version compatibility, something like that. Tick token is yet another library from OpenAI that allows you to perform tokenization efficiently. And we are installing these, and then you could see we are performing some embeddings like langchain.embeddings.openai to get the OpenAI embeddings. We have character text splitter, then we have, this is Facebook AI similarity search, because as I told you earlier, we are going to perform similarity search, then loading the text data, because we have a text file, and then we are kind of loading a whole text file. And then you have recursive character text splitter. This is like a more intelligent character text splitter. Okay, it kind of works in a more intelligent way. So even any kind of words or any kind of character that are there, it pushes them intelligently. So you can use that. And then I'm using Google Colab user data, because I've added all my keys here. You can see I'm going to delete all these keys and give this link to the give link to this Colab notebook in the description. So as soon as you have this notebook, make sure you add all these keys. OpenAI API key, I'm sure you already know about this. And then you have the Pinecone API key, and then you also have the Pinecone environment. You can copy this, and the index name is your project name. Like here is Aristotle, something like that. So you can just put in here, and then make sure you allow the notebook access, and then you're good to go. So that's how you read it. And you have to run this only when you have a new vector database. Okay, if you don't have one, then don't bother running this cell. Okay, if you want to create a huge like a completely new vector database and push a whole new data to it, in that case you can use it. Otherwise, if you already have created one from here, then you don't really have to do that. And if you have some knowledge already present in that, okay. And then this is for existing database, as I made it very clear for you. You can push new data to your existing vector database. Here you could see I'm using this latest_news.txt. This is one such file that I have. So pushing this to the same vector database that I've created. Now loading the data, you could see I have 2783 characters, which is pretty low. It is just for an example. And then you are splitting the text and splitting documents, and then pushing it to the data. Here, if you want to run it within the cell, you can also add OpenAI keys here. Totally up to you. You can see another vector database is Chroma. If you want to use it, you can do so. Otherwise, I'm using Pinecone here. And here you can see we are again performing some OpenAI embeddings. We are using text embedding, ADA model. You can try different models, but it's more or less the same, I believe, when you're working on a very simple use case. Other than that, here you could see we are performing some document search. Pinecone from text. It's like this is just to call it, so I'm giving it an empty text, and then you are giving your index name that we have added as an environment variable, and you keep going. And then I'm using GPT 3.5 Turbo Insect, because the DaVinci model has been deprecated recently, so in order to avoid it, you have to use it this way. Just write GPT 3.5 Turbo Instruct here. This is how you have to use it. Otherwise, it throws an error that DaVinci has been deprecated. Now I give you an example. Okay, so the vector database that I have is of Elon Musk. I have scrapped down some of the interviews of Elon Musk and some of the articles that I found on internet about Elon Musk, and I am using it as a knowledge base. And this is not the vector database that I'm using. This is just for an example. The one that I've shown you for Aristotle is just an example. I'm not using it. I'm using a whole different vector database. So one such query that I'm giving right now is, how many hours do you work? and then I'm performing similarity search on the query, and then we are going to retrieve some results out of it. You could see the context like this. The result is the speaker does not give a specific number of hours they work, but they mentioned working 22 hours a day, 7 days a week, and sleeping in the factory. This was present in the knowledge base that I've provided. Okay, so that's how it works. Now I will show you how do you use, like, how now that you have learned how to do the retrieval thing. So it's RAG, right? So you are done with the R thing. Now let's talk about augmented. So this is one such function that I've created for Elon. Yes, Elon Musk. You can see I've added a system message like you are a personal assistant of Elon Musk, the visionary entrepreneur, and stuff like that. And then I have added context. You can see I have added one such variable. It's called context. Context is the same thing that was retrieved from the vector database. Okay, just go through this and you will understand everything. It's very simple. So we are using context, and we are providing it to the system so that the system is fully aware of what's going on. All right, and then we have the query, the conversation, everything, and chat completion. I'm using 3.5000613. You can use any of the models that you want to. And here you could see the question that I have is, which university did he go to? So I'm talking to the personal assistant of Elon Musk. You could see you're a personal assistant of Elon Musk. This is how the model will behave. So you are a personal assistant of Elon Musk. So tell me, which university did he go to? And the model responds, Elon Musk attended the University of Pennsylvania where he studied physics and economics. However, he left completing his degree to pursue his entrepreneurial ambitions. It provides short responses because I've set a limit to the max tokens 150. Now let's talk about something else. And let's see how good the model is. Uh, mm, can I book an appointment with Musk? Let's see what it responds with. So, okay, I'm afraid that scheduling an appointment with Elon is quite difficult at the moment. His commitment and projects keep him extremely busy. However, I'm here to assist you with any questions or information you may require. How can I help you? See the way the model behaves right now. So it's so good that you actually feel like you're talking to an assistant of Elon Musk, right? So this is how you can make things very simple, and you can make things work to your own use case when you use retrieval augmented generation. So this is definitely not imitation, but this is just about how the model is fully aware of what we are talking about. And if I give the same example here, let's see how the model would behave. Like, how busy is Elon Musk? How busy is Elon Musk? So this is a query that I've given, and let's see what the context returns. Okay, it returns I don't know, because I think there's no such match result that the model has found. So in that case, this is what it says. I don't know. Otherwise, let's say let's see, when did he start Tesla? See, one thing that you have to understand is the response that we are getting from the vector database is not as good as we expect it to be, right? Because we are using a instant model here, not a chat completion. So the model responses that you are getting is not more like a one-on-one thing. But if you use the same in your Elon function, you could actually see it how beautiful it works, right? It behaves perfectly fine even if the similarity search does not perform well, and if there are no such efficient results out of it, even if there are no such good similarity search results coming from the vector database, it still works in the best way possible, because we have provided a system message and then we are also providing it additional context. This is how it works. Let me remove this, and let us ask another query. Once this last query, ask Elon if I could get a free Tesla. Let's see. Unfortunately, I cannot directly ask, but I can tell you that obtaining a free Tesla would greatly depend on certain circumstances. Okay. Yeah, so this is how it works. Of course, this is working on a very small knowledge base, because I don't really have much, like a huge knowledge base of Elon Musk. So I just grabbed down a few interviews and a few articles I found on internet, and then I put them into a text file, pushed it to the vector database, and then retrieving results out of it. This is how it works. But if you have a good amount of knowledge base, then you are gonna get a lot better results than this. So thanks so much for watching this video. Other than that, we can also learn few short learning, and also if you want to learn more about fine-tuning and stuff like that, then just let me know in the comment section. I will be very happy to make videos on that. And don't forget to follow me on my GitHub. I have a couple of projects here that might be interesting for you, so you can just use these projects and work on. If you want to contribute, you can do so. Also, you can go to my Hugging Face account, and I have a couple of spaces available here. You can probably try them out and have some models. So you're good to go. You can have fun with those. So thank you so much once again for watching this video. Until then, see you next time.